Greetings class, Dr. Williams here, Theory of Individual Behavior, video 3 of 3. Here's a slide I took from the first video. We're looking at these three choices faced by individuals. Video 1 looked at this one, and then video 2 looked at this one. This leaves the final choice, how much and what to buy now. So we're going to look at this one in this video. Of course, these three are all related, and really we should look at all of them simultaneously, but to keep things from getting too complicated, we're looking at them separately. So, let's move on. How much to buy and what to buy now? Benefits and cost of each purchase. So when you buy something, it has usefulness. Think about eating a hamburger. You're hungry, you pay for the hamburger. While you eat it, you're happy because it's satisfying your hunger. The cost of the product is the price you pay. If the hamburger costs you $4, I guess that would be at McDonald's or Burger King, my favorite hamburger restaurants, then you gave up $4 that you could have used to, say, put a little bit of gas in your car, or buy a cup of coffee the next morning at the Starbucks. So when you think about the benefit cost ratio of an item you purchase, the benefit goes on top, marginal utility. That's the increase in happiness you get from consuming a product. And the cost is the price. So the goal of an individual is to find the things that are within the individual's budget that have high margin utility to price ratios. So when I go to McDonald's, I tend not to buy the $4 burger. I tend to buy the $1.29 McDouble because I'm not too picky, and it's cheap, and that leaves me more money. For example, I have to pay tolls on the way to work, so I can pay the toll. Instead of paying $4 for the burger, I can pay the toll and have a cheaper burger. So anyway, everybody is different. Everybody needs to figure out their benefit cost ratio for each item that they can purchase. So here's this thing called the utility maximizing rule. This is a very famous rule in economics. A person maximizes her total utility achieved from purchasing products when she buys items that have the highest margin utility over price for her. And you keep doing that until you have no more income to spend. So this is actually a very tricky thing to do in practice. I don't know that real human beings actually do this, but you would have to sort of make a list of everything in the world that's available for you to buy that you can afford. And then you have to figure out how much happiness you get from buying each one, and you have to know the price of each one. And so then you determine this ratio for each one, and you start buying the things that have the highest ratio, and you keep buying them until you have no more money to spend. Now that's a very tricky thing. Think about just going to the grocery store. Do you really see? Some people, my wife will tend to make a shopping list, and thinking about things that are necessary to buy. On the other hand, when I go home for Christmas and I go to the grocery store with my dad, it seems like everything he bumps into, he just throws it in there. I mean, he's not rich, but it's like, oh, look at this, and he throws it in there. That's certainly not following the utility maximizing rule. But if you think about what a firm would want to do that's trying to make profits, what do? You use marketing to inflate this. You say how great the thing is without breaking any laws and lying. But you use marketing to inflate this, to increase it in the eyes of consumers. It's the perception of usefulness, not the actual usefulness itself. And then you use a pricing strategy to make this seem lower. Now, how can you make a price seem lower? You can break it up into multiple parts. Think about your cell phone bill. Now, I like the prepaid cell phone where the price is the price. I pay $30 a month, and that's it. I like that. But of course, a sneakier strategy, AT&T and Verizon tend to do this, in these postpaid plans, is they'll advertise a price, $30 a month, and then they'll add all these things that seem like government taxes and fees and all that, when they're actually just ways to make the price seem smaller than it is. Or you can break the price into payments, things like that. Or of course the strategy of using the 99-cent, which is an old strategy. Instead of charging $2, charge $1.99. Now that technically it's a penny lower, but in the mind of people it's much lower than $2. And of course, advertising, there's all kinds of strategies to inflate the perceived usefulness of a product, and that is discussed more in the marketing class. But the idea is you want the individual to think that your product has a high marginal utility over price ratio, and then they're more likely to buy it. Now, can we illustrate the options available to a person? The only relevant options are the things that are affordable. So for me, the fact that I might get a lot of utility out of a house that costs $5 million is irrelevant, because I can't afford that. So we need to have a way to represent the options that are affordable to a buyer. And there is such a thing. It's an equation called budget constraint. So the idea is each person has a limited income he can spend today and must spend it on a limited number of products that are within his budget. A budget constraint is a mathematical representation of a person's buying choices. And it has to include the following two things. The person's total spendable income, that's the budget, and the prices per unit of each product that the person can choose to buy. When you have those things in an equation, you get a budget constraint. Now, in the real world, it's pretty easy to figure out what your income is. The prices of all the products you can afford to buy, that's very, very hard. You can think about all the prices of stuff at Walmart. I mean, I think I could afford everything they sell at Walmart. I don't know all the prices. So it's a difficult thing to do in the real world. So as usual, we'll do a simplified example. So here's Jimmy. He has $100 to spend this week. So that's his income. Right? And then we assume he only can buy 3 types of products. Hamburgers, which are $2 each, beer, $5 per 6-pack, gasoline, $3 per gallon. So let's create Jimmy's budget constraint. You put the income on the left, and then you put the products on the right. Let me start with hamburgers. Here's the price per hamburger, 2, and we have a letter representing the quantity of hamburgers that Jimmy will buy, in this case H. So H is a quantity. H is a quantity of hamburgers. It doesn't just mean hamburger. It's a quantity of hamburgers that Jimmy buys. And we put a plus sign. We put the price of beer, 5, and we have to have a letter that represents quantity of beer. So I'll use B. B for quantity of beer. So B is a number. it's the quantity of beers that Jimmy buys. It doesn't just mean beer. B is not short for beer. B is short for quantity of beers that Jimmy buys. And then we need the price per gallon of gasoline and a letter that represents that. Now, when you create an equation, you probably should tell the people reading the equation what the letters mean. So we're going to do that down here. We're going to say H is quantity of hamburgers bought by Jimmy. B is quantity of 6-packs of beer bought by Jimmy. And G is quantity of gallons of gas bought by Jimmy. So equations are useful not only for our own purposes, but if you're going to put budgets in computer programs, you have to tell the computer what the budget is and what prices are, and generally you put it in as some sort of budget constraint. This is true for people. This can also be true in for businesses. What they have a certain budget to spend on costs of production, and this is for a consumer spending on consumer goods, but it's the same idea for businesses. Now, you can use the budget constraint in many ways. I have two examples that I've made up. Here's the budget constraint. I put that letter wrong there. 2h plus 5b plus 3g, right? Is that what I had? Yeah. 5b plus 3g. So let's use this budget constraint. Can Jimmy afford to buy 10 gallons of gas, 8 6-packs of beer, and 15 hamburgers? Well, we have to see how much they cost and whether it's $100 or less. So what do we have to do? I'll just copy this and put it down here. We need to put in a number for H, a number for B, and a number for G. So we have 2 times, I think I can use the X. So H is quantity of hamburgers, 15. This is H here. Let me just put a little notation. This is H, so we put it in. That's $30 spent on hamburgers. Again, you don't really need this equation to answer this question. If you want to answer it another way, that's fine with me, on a test. But it's useful to be able to use equations in the real world if you're working with software and things like that, or even an Excel spreadsheet. So now we put 5, which is the price per a 6-pack of beer, and now we need to put the quantity of beers, 6-packs. That's 8. That's a lot of beer. Jimmy's an alcoholic. Put an 8 in there. And we need to do finally the same thing for the last part of the budget constraint. $3 per gallon of gas, 10 gallons of gas. Now we need to see how much this is. If it's less than $100 or equal to $100, he'll be able to buy it. So it costs exactly $100. What a coincidence. So answer is yes. Because it costs, because Jimmy has a $100 budget, and the total amount of money he needed to buy those products is also $100. So if the total was more than 100, he wouldn't be able to afford it. If the total was less than 100, he hasn't used all of his money. So let's do another example of using Jimmy's budget constraint. There's the same. Oh, there's the same budget constraint. I got that letter wrong there. Let's see. If Jimmy buys 20 burgers and six packs of beer, then how many gallons of gas can he afford? Now you don't need to use the equation for this to get the answer, but let's do it anyway. So let's put this thing down here. Now we know the values for two of these things. The hamburgers, let me make that hamburgers. There's 20 of those. So this is H. Six packs of beer, that's B. We don't know gallons of gas. That's the question we're having to answer actually. What is G? So let's put in the numbers for H. Two times 20, that's H. B is 6. We have that. We don't know what G is. We're trying to figure out what G is. So if we do some math, we'll be able to get this. Let's see. 100 equals 40. 2 times 20 is 40. 5 times 6 is 30. Keep going with the math here. 100 equals 70. 40 plus 30 is 70. And we can subtract 70 from both sides. In other words, this leaves Jimmy with $30 to spend on gas. Now divide both sides by 3. So the answer is he can afford 10 gallons of gas. So the budget constraint can't tell us what makes Jimmy happy. So it can't tell us exactly what he will end up buying. But it can sort of tell Jimmy the options he has. He could theoretically make a list of the options and pick the one that maximizes his happiness. So that's the end of this video. We just did number 3. Till next time, Professor Williams is saying, have a good day.